Calculate the value of x in this infinite geometric series. So here we have sum of an infinite geometric series, and the sum of an infinite geometric series equals a over 1 minus r. A is the first term, and r is the common ratio, what we multiply by every time to get from one term to another. And in the infinite geometric series, to have a finite sum, r has to be between -1 and 1, which means it cannot be bigger than 1 or less than -1. That's for the infinite geometric series to have a finite sum. That's the only way we could find the sum of an infinite geometric series. Why? Because if r is a big number, like let's say if it's 2 or 3, then every consecutive number in the series will be bigger and bigger and bigger. So you cannot really find the sum. But when the r is a fraction, let's say it's a half, and each term that comes after is half of the term before, later on in the sequence or the series, the numbers become so small that they become irrelevant, they're insignificant. So that's why r has to be between -1 and 1. Okay, so now here, what do we need to do? The first thing we need to do is figure out our r, what the common ratio, what are we multiplying by to get from one term to another? As you see, the only thing that's changing going from one term to another here is the number in front of the log. So 1684, it seems like this number is halving every time. So my common ratio, which is r, equals 1/2. And the first term with a, this is basically just this thing right here. And the first term is 16 log base root x 64. Now let's go to this equation here and I'll start subbing where everything goes. So of course, here they gave me the sum and they want me to find x. So the sum is this. So s is right here. They gave it to you. So we could start off with 64 over 3 equals a, which is 16 log root x 64 all over 1 minus r, 1 minus a half. Now, this is 64 over 3 equals 16 log base root x 64 over, and 1 minus a half is just a half. So what I'm going to do after this, I'm going to cross multiply this number right into the 64 over 3. So basically you're going to have 64 over 3 times 1/2 equals 16 log base root x 64. Now I'm just going to simplify here and reduce the fraction. So that becomes 1. The 64 becomes 32. So I have 32 over 3 equals 16 log base root x 64. And now I'm going to cross multiply the 16 to the bottom right here. So the 16 is here. When it moves to the other side of the equal sign, just going to go with the 3s. And you know what? I'm going to go 32 over 3 times 16 instead of multiplying them right away, because now I know the 16 and the 32 will reduce. That's 1, that is 2. So and that is basically log root x 64. Now what I'm going to do, I'm going to move all of this to here. So we have 2/3 equals log base root x 64. And now I'm just going to show you how to change from logarithmic form, log base a x equals b. You could change that to exponential form by going x equals a to the power of b. So this is the base. The base raised to the power of b gives you x. So here basically, so what you do when you're going, this raised to this power gives you the 64. So I'm going to have root x raised to the power of 2/3 gives me 64. I'm going to change root x to the power of 1/2 because that's changing from radical form to exponential form. And I have the 2/3 here equals 64. Now, when you multiply 2/3 times 1/2, you end up with x to the power of 1/3 equals 64. Because 2/3 times a half, the twos would cancel, you'll end up with 1/3. Now, to solve for x, you got to cube both sides. So I'm just going to cube this, and I'm going to cube this because the cube will get rid of that. 1/3 here, 3 times 1/3 is 1, so that would be x. And 64 to the power of 3 is just going to be a huge number. And x will be 262,144. And this is basically the answer to this, what looks like a complicated question. Just break it down and you'll get to the answer. As always, thanks for watching. Till next time. Bye-bye.